Hello, everybody, and welcome to the live stream of Illusions Exist. Um, I'll have to say, I've still been watching Gary, so I admit this is not a response to him, but it is inspired by how stupid he is at physics. Now, I had a whiteboard presentation set up, but the whiteboard stuff isn't working. This pen here and stuff. So let me just say about that is that you've got, just to remind everybody, you got mass, right? You got space, which through distance, and you've got time, right? Mass, space, and time. And in physics, specifically physis, that's all you've got, according to the mainstream theory that has been the branch of natural philosophy studying it. Like, physics is focused on mass, time, and space, distance, three-dimensional distances. And that's what we have to deal with. Now, there's other things in our lives, but that is what we have to deal with. Now, so you've got those three things. Now, if you take distance divided by time, distance per time, you get velocity. What do you get when you get distance multiplied by times? That'd be a different question. So that's velocity. Now, to bring in mass, you can times by the velocity, which is mass times distance over time. That's momentum. Force is momentum divided by time, or distance divided by second squared, which is the same exact thing mathematically, right? And energy is just force, which is momentum over time, multiplied by a distance. And if you wanted momentum again, you would go force times time, and you would get momentum. But of course, you already had momentum, because momentum is sort of the first thing, the first little combination of mass, distance, and time that we have that seems of, good use is momentum. Mass times distance divided by time, otherwise known as mass times velocity. Hello, J. Troy. Do you have an alert or something? Anyway, now what I have here on the screen is the Khan Academy. What are elastic and inelastic collisions? And we're just going to go through that. I was going to do a bunch of stuff on my whiteboard first, or maybe as an alternative, but, it didn't work out. My whiteboard isn't working. So let's just go through this. What is an elastic collision? An elastic collision is a collision in which there is no net loss in kinetic energy in the system as a result of the collision. Both momentum and kinetic energy are conserved quantities in elastic collisions. Now, that never happens. However, it's a pretty good approximation. Not much energy is lost to heat given certain kinds of materials. Like clay is not a good elastic material, but most materials, from plastic to steel to things that retain their shape, are elastic enough that any calculations based on elastic collisions will be pretty accurate. I think we all know that. Suppose two similar trolleys are traveling toward each other with equal speed. They collide, bouncing off each other with no loss in speed. This collision is perfectly elastic because no energy has been lost. So that's what they're proposing. In reality, examples of perfectly elastic collisions are not part of our everyday experience. Some collisions between atoms and gases are examples of perfectly elastic collisions. However, there are some examples of collisions in mechanics where the energy loss can be negligible. These like billiard balls. These collisions can be considered elastic even though they are not perfectly elastic. Collisions of rigid billiard balls or the balls in a Newton's cradle are two such examples. I think we're all familiar with that. Why would we ever approximate a collision as perfectly elastic? Given that no mechanics problems we are likely to encounter involve a perfectly elastic collision, it may seem that the concept is of little practical use. However, in practice, it is often very useful. This is because the requirement that kinetic energy is conserved provides an additional constraint to our equations of motion. This allows us to solve problems in which we would otherwise have too many unknowns. Often, the solution will be quite adequate because the collision is close enough to perfectly elastic. Now, suppose we have a head-on collision. It occurs between two trolleys A and B on a track. We want to know the final velocities for both the trolleys, but are only given the initial velocities v sub ai, I for initial, and v sub bi. So object A, velocity initial, object B, velocity initial. Applying conservation of momentum, we can see that we have one equation with two unknowns. The velocity of A final and the velocity of B final. That's what we're trying to find out. The velocity of object A in the end and the velocity of object B in the end. And then you get this equation, right? So the mass of A times the velocity of A initial plus the mass of B times the velocity of B initial has to equal the mass of A times A's final velocity plus the mass of B times B's final velocity. Now why? Because the total momentum has to be the same. This is the momentum of A, A's mv. This is the momentum of B's mv. So if you add those together, they need to equal the final velocities. Now notice that since a mass can be reflected and start going in an opposite direction, that's a negative direction to its initial direction, velocities can be negative. So these things need to add up, including negative numbers, allowed to be equal. The momentum in the beginning and the momentum in the final. Now, because kinetic energy is... Now, look at this. The problem here is we have two unknowns. Velocity sub A final and velocity sub B final are unknowns. And we only have one equation. That means you can't solve it. You need as many equations as you have unknown variables. Okay, so because kinetic energy is also conserved, we simultaneously have another constraint. And that is the kinetic energy of A. So that's 1/2 mass of A times the velocity of A initial squared. And the kinetic energy of B, adding those together, has to equal the kinetic energy of A in the final state plus the kinetic energy of B in the final state. So those have to equal in an elastic collision. So a little tiny bit will be lost, but a little tiny 1%, less, 1.1%, whatever. Very small. So the kinetic energy also has to equal two equations and two unknowns for those that paid attention in middle school, mean that you can solve these equations. You have two equations with two unknowns, therefore you can solve it. Now, they say solving the equations is somewhat tedious. I don't find it tedious, but then I'm a scientific data pipeline programmer, so, that's easy. For now, we simply state the result. Okay, so you can do the math yourself, some of you, and you will get this. So this is the velocity of A final and the velocity of B final in terms of known quantities. Right, mass A, mass B are both known, so you got mass A minus mass B over boom boom. You got the velocity of A initially, you got the second mass, you got them added together, and then you got the initial velocity of B. Similarly for the final velocity of B. Now you could look at the proof here if you want. So that's why we need both concepts and why both concepts work together. All right, because with just momentum or just energy, it's hard to know how the things are going to actually move. Now, with momentum, you get direction. And with energy, you get a constraining equation. And what a lot of people don't take into account is when cart A hits cart B, if they're the same weight, it's just like pool balls and a stop shot where the ball you're hitting with stops and the ball you hit moves at the same momentum with all of the energy. But in real life, most collisions are, a smaller object hits a bigger object, and it's going to bounce back. And so it's still going to have a velocity, a negative velocity, and that has to be counted into account, right? And it could be the other way. A bigger object hits a smaller object, and while the bigger object doesn't bounce back, it does knock the little object, which goes shooting off, and keep moving a little itself. And so these are the details about what you have to add up and why you need both concepts. It's a very good article that certain people, I don't know, people in New England, people in, New England should read. It's very illuminating. So I think that does it until I can get my whiteboard working again, in which I can go through the three types of values and what they all mean. Mass by time, time by mass, distance by time, time by distance, time by time even. Like a watch can be time by time. Like, what do you mean? Well, I have a watch and it loses 1 second a year. It's time by time. So you can have all of them, mass by time and time by distance. You can have mass by distance. How could you have mass by distance? Well, let's say you have a pole and it's got a certain mass for every distance length upon the pole, right? All of these mixtures, mass by time, time by mass, distance by mass, whatever, they all have a meaning. Some of them more, useful in a day-by-day context. But they all have a meaning, and so do when you start taking, something like momentum that has mass, distance, and time in it, and adding another time, or another distance, or another mass, divided or multiplied. Because division and multiplication both have physical meanings when you're doing them with these three physical values or quantities. Now, it's worth pointing out that most car wrecks, most car collisions are really not very elastic. But you can still do physics on inelastic collisions. I think that's been shown as well. But it is worth noting that unlike billiard balls, auto accidents not so elastic. And if they were elastic, it wouldn't be that great because, the jerk and acceleration in elastic collision of changing direction almost instantly is, not so great on the human body. J. Troy Doe, I'm kind of talking to you. All right. Cheers to everybody. And may you all have a wonderful weekend like I had. I just got... Oh yeah, I was gonna add that, but now it'll be hard to add that. Okay. Picture of I got a boat. I got a pontoon boat because, as some of you know, I live on a pond, which by California standards would totally be a lake. But in Maine, whatever, it's a pond. And so I got a pontoon boat, and it was a stripped down, it was like a base model pontoon boat, stripped down, turned into a workboat covered with basically plywood. So it's basically plywood with a little 4x4 stand for the steering wheel. You have to stand up. Excuse me. And so it's just plywood. So today we did a couple things. One, we covered it with AstroTurf. Now, AstroTurf has gotten really high tech. It's not like your old 80s AstroTurf. This AstroTurf it's the cheap kind of a kind that is basically looks like grass. Like, it's fairly pleasant to lie on and stuff. It's got little brown strings in the bottom, makes it look very much like grass. And there's way better kinds as far as if you really want your AstroTurf to be like grass. But anyway, so it looks like a lawn now. Plus, I screwed a hook on there so that I can attach the rope to the top because it was just around the pontoons. Being a workboat, it didn't really hang out at a mooring very often. I park it by my permanent dock, a wood dock that I have out in the lake. But anyway, so I added a ring there so I can attach, and my ropes that I attached from the back, I still left those spots, but I bought some chain and a chain cutter, a bolt cutter, so that I could make chain of a certain length so that I wouldn't have to always tie the rope just right, because if you get it wrong, it bounces against the dock, it gouges it and stuff. So I got a couple lengths of, I got one big 15-foot length of 3/4 inch chain, and then, no, not 3/4. Like whatever the size is smaller than 1/4. What is that? 3/8, and I think. And so I made a couple links of chains and some. They're not carabiners, but they work like a carabiner. Just some clips. They go click, click, click. So it's all perfect. So when I land it, I can just go click, 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 and it's all just right to not gouge my dock. And we did all of that work today. I've done some work before on it. We have a lot of ideas for it. We put a couple 4 USB speakers on it where you can pair with one of them, and then you just click the other 3 and it plays out of all 4. So that's pretty good. So summer's going pretty good, and yet I have this issue with explaining physics to people that don't understand it, and they don't want to understand it. Weird. All right, take it easy, and thanks for joining Illusions Exist. Something that's absolutely probably going to happen a way lot more, right? Right? Do you believe that? Yeah, right? Probably not. Okay, bye.